All right, this new unit is going to discover all the different properties and laws behind exponents. Right, so you're going to learn things about exponents that you never dreamed existed, and you will have to know and use them appropriately. So the first part of our lesson starts with multiplication properties of exponents, and there are 3 of them. You will need to know them not only by name, but by what they look like and what they mean and say. Right, so the first thing we want to do is talk about the product of powers property. Product meaning multiply, powers meaning things with exponents. Right? So this law or this property says that to multiply powers of the same base, you will need to add the exponents. So the base stays the same, but the exponents get added together. And for each one of these properties, I will give you a few examples to go with it so that you can make sure you're understanding what each one is saying. Right? So here are the examples that go with the product of powers property. Right? If you have 5 to the 3rd power times 5 to the 6th power, right? Then what that is the same as is that the base is both 5, so that means in your answer your base will stay a 5, but you're going to add the exponents together. 3 plus 6 is going to give you 5 to the 9th power. And here's why this property exists the way it does. 5 to the 3rd power is 5 times 5 times 5. Right? 5 to the 6th power is 5 times 5 times 5 times 5 times 5 times 5. Okay, and if you go to simplify them or combine them together, you're really counting up how many 5s you have. Well, you have 3 right here and you have 6 right here, so that's a total of 9. And that's how this law came about. It makes your life so much easier, especially when the exponents get quite large, that you don't have to write that out every single time. Right? So it's like a shortcut of sorts to get to the answer without having to write everything out. Right, so another example would be if I have x times x squared times x cubed times x to the 4th. Right, the base in this problem is x. So in my answer, my base will remain x. Right? It's the exponents that I now need to add. Now, if you don't see anything attached to this first x, remember 1s are invisible. They still hold to be true. So now you want to add all of them up. 1 plus 2 plus 3 plus 4 is going to give you 10. So this answer is x to the 10th power. Right? For the next one, if I have 3 times 3 to the 12th power. Okay, my base is 3, but remember this first one has an exponent of 1, because there's only 1 3 right there, right, that you need to understand exists. So when you go to combine them, you still have a base of 3, but now 1 plus 12 is going to give you 13. So this is 3 to the 13th power. You are not evaluating them, you are simply simplifying the exponents to them by using this property. Right, so the 4th and final one we'll do under this property is going to be some negative numbers. If you have negative 2 in parentheses to the 5th power times negative 2 in parentheses to the 7th power, right? Your base is negative 2 in parentheses. You must keep those parentheses around that negative 2, otherwise you have changed the base. Then if you add 5 plus 7, you get 12. So negative 2 in parentheses to the 12th power becomes your answer. The next property is known as power of a power property. Right? And what this becomes is that you have an exponent raised to another exponent. So you'll be able to spot this one every single time very easily because of the way it looks. Right? But here's what this law says to do. To find a power of a power, you are going to multiply the exponents. So above, when we had a multiplication problem and they had the same base, we were able to add the exponents. But this time, you're only going to have one base, but it's going to have 2 powers in it, which means you're going to have to multiply those 2 powers together to get your answer. Right? So the first example is 3 to the 5th power raised to the 2nd power. And here's where the whole power of a power comes from. 3 to the 5th is a power already, but now you're raising it to another power. Right? What this is really saying is that you have 2 3 to the 5ths. So it looks like this. And we know that if our base is the same, then we're going to add exponents together. Well, it's a lot faster to just say that my base is 3 and 5 times 2 is 10. You get the same answer and the effect of it is a lot quicker, right? But that's how and why it works, right? For number 2, if I have y to the 4th power raised to the 9th power, okay, we're going to simply take and multiply our powers together. So this becomes y to the 36th power. Okay. For number 3, okay, you're going to have negative 3 in parentheses to the 3rd power, and then you're going to see brackets, and the only purpose of the brackets is because the parentheses have already been used. If those parentheses weren't used, then those would have been parentheses, right? But because they're brackets, then they're going to hold another power on the outside. You do exactly the same thing we've been doing. Ignore the brackets and multiply the powers, but keep that negative 3 in parentheses because you can't do anything to it. So 3 times 2 will be a power of 6, right? But those parentheses have got to remain there because they're holding the negative number together. Okay, and then the 4th one, go ahead and put a star next to it because this one becomes the trickiest one for students to remember. It's not difficult to do, it's just tricky to remember what you're supposed to do with it. You're going to have an expression in parentheses, right, with a power on the outside, and then you're going to have those brackets again because the parentheses have already been used with another power on the outside. So when you have this, drop the brackets and keep everything the same that's in the parentheses. Do not change anything in those parentheses, and then deal with your power of a power piece. 3 times 7 will give you 21. So the answer to this problem is parentheses p plus 1 to the 21st power. Okay, you do not do anything else with that. All right, the third property is the power of a product property. All right, and with this one, to find a power of a product, find the power of each factor and multiply. And I'm going to put in parentheses that this is like distributing. It is not the distributive property, but you're kind of doing the same thing. You're just distributing an exponent to everybody in the parentheses instead of a big number on the outside. So here's what this one looks like. Right? If I have 4yz raised to the 3rd power, right? The power of 3 on the outside is being given to the product of 4 times y times z inside. So you're going to take this 3 and you're going to give it, like distributing, to each piece of the product. So this becomes 4 to the 3rd power times y to the 3rd power times z to the 3rd power. Now, one thing you have to make sure that you do, you cannot ever have a coefficient in front of letters that's a power. So we have to turn that into a regular number at this point. 4 to the 3rd power really turns into 64. So your final answer for this problem is 64 y to the 3rd power z to the 3rd power. Right? Remember, your variables need to stay in alphabetical order. Okay, so that's the trickiest part about this one, is that not only do you have to distribute your powers, but you have to watch out for those coefficients. Right? So here's another one. Right? If I have in parentheses negative 5w to the 4th, okay, and it's raised, sorry, negative 5w, and then we'll put the 4th on the outside. We want to do it this way. Okay, that 4 is going to get distributed to everybody inside, so it's going to go to the negative 5 and to the w. But be careful, because this is a negative 5 and it's already in parentheses, you have to do negative 5 parentheses and then raise it to the 4th power, or you mess up your value. And then w to the 4th power. Again, you can't have a coefficient that's a power, so we need to turn that into a regular number. If you type in negative 5 in parentheses to the 4th power, right, you're going to get 625. And then w to the 4th power. Right, so that's the official answer right there. Then if we go to do these next two, I'm going to do them simultaneously because I want you to see the difference between how they look. The first one is going to be in parentheses negative 2w with a squared on the outside. And then the next one is going to be negative on the outside with 2w squared. So it looks like this. So the only difference is where that negative sign is located, and it does affect your answer. So I want to show you how to deal with it and what to watch out for. The 2 that's on the outside of this parentheses goes to the -2 and to the w. So it's parentheses -2 squared times w squared. Over here, though, this 2 goes just to the 2. So it's 2 squared times w squared, and then you drop the negative down. Right? So now over here, when I'm evaluating my coefficient, -2 in parentheses squared becomes +4 w squared. So that's my official answer on this one. Over here, when I go to do my exponent, because it's not in parentheses, 2 squared is 4, and then bring your w squared down, but that negative sign has got to stay there. So this one becomes -4w squared. So that negative on the outside versus inside does change your whole entire answer. All right, the last thing that we're going to do with these properties is combine all 3 of them together, and that's really what you need to be able to do for algebra. Knowing them separately is not going to get you very far, but being able to put more than one of them into a problem together, you'll be more successful with that, and that's how you're going to see it on the SOL as well. All right, so when we take a look at this first one, we're going to have parentheses 4x squared y, parentheses raised to the 3rd power, times x to the 5th power. This problem has all 3 properties in it. Right? The first thing you want to make sure you always do, just like in an equation, is distribute. So I need to give this power of 3 to the 4, to the x squared, and to the y. So when I bust it apart, it's going to be 4 to the 3rd power times x squared to the 3rd power times y to the 3rd power, and then bring down times x to the 5th. Right. The next property you want to take care of are your power of powers, your exponent raised to another exponent right here with the x. We multiply those together. Right, so that's x to the 6th times y to the 3rd times x to the 5th. And then we can go ahead at this point and turn our 4 to the 3rd into a regular number, because remember, we can't have powers in our coefficient. So 4 to the 3rd power is 64. Okay, but you're not finished yet. All right, we've got powers that have the same base. This x to the 6th power and this x to the 5th power can go together. There's no reason to have them separated. Combine them together by adding the exponents. Right, so we have 64 as our coefficient, we have 11 x's, and we have y to the 3rd power. So this becomes our final answer. And look how simplified that is compared to what you started with. That's the whole point, is to take these problems and simplify them as far as you can go. All right, so the next one, we'll have 6d to the 4th power, all squared, times 1/4 d to the 3rd power squared. Okay, so don't panic now because you see a fraction in your parentheses. That's not nothing to panic over, right? We're going to take and treat it like we normally would. Take your powers on the outside and distribute them or give them to everybody inside. So that's 6 squared times d to the 4th squared. Okay, over here, this is going to be 1/4 squared times d to the 3rd power squared. Okay, so that's just the distributing part. Now for the next part, you want to do your power of a power, which is your exponents raised to exponents. Right, d to the 4th squared is going to be d to the 8th. Remember, we multiply those. Okay, and then over here, d to the 3rd power squared is going to be d to the 6th. Right, now let's go ahead and take care of our numbers while we're at it. 6 squared is going to turn into 36. Still keeping that times dot there. For 1/4 squared, in order to square a fraction, here's how easy it is. You square the top and you square the bottom. So 1 squared becomes 1, 4 squared becomes 16. Right, so you just squared that 1/4. Right, now we're not quite done yet because there's some more that we can put together. Right, we can combine our numbers together. The 36 right here and the 1/16 are just regular numbers. We can multiply them together, right? And when you do that, you end up, remember, this is 36 over 1, so multiply 36 times 1, which is 36, and 1 times 16, which makes 16. Okay, we'll reduce that at the end. Okay, and then actually let's go ahead and reduce it here. 36 and 16 can divide by 4, right? So once you divide by 4, you're now down to your new coefficient of 9 over 4. Right, then we can put our d's together. We have d to the 8th and d to the 6th. There's no reason to keep them separated, so we combine them. 8 plus 6 gives you 14. This is your final answer. Okay, so don't panic over those fractions. They're not that bad to work with. We'll take and deal with them as they come through, but they will be there and they will exist. Okay, we have 2 more of these, and then we'll see from class how you guys feel about the things you've seen so far. Negative 3xy squared to the third power times negative 2x squared y to the second power. Again, first things first, distribute all your powers to everybody. So the negative 3 gets a 3, x gets a 3, y squared gets a 3. At this point, you might be comfortable with taking your powers of a power and going ahead and multiplying them. If not, write them out separately. I'm going to take and bridge you to the point where you are going to be comfortable. So in parentheses, negative 3 to the power of 3. Then you're going to have x to the third power. Then you're going to have y to the sixth power. Remember, power of a power, 2 times 3. Now on the other side, give everybody the power of 2. So this will be negative 2 squared, x to the fourth power, because 2 times 2 is 4, and y squared. All right, now we want to deal with our coefficients and then putting our terms with the same base together. All right, so let's go ahead and turn our powers into regular numbers. Negative 3 to the third power is going to give you negative 27. Negative 2 squared is going to give you positive 4. Right? Because these are just numbers, you're going to multiply them together. It's a big old multiplication problem. So negative 27 times 4 is going to give you negative 108. That's your new coefficient. Now you want to combine your x's and your y's together. I can put these 3 x's right here combined with these 4 x's, and now I have x to the 7th power. Okay, then I can take and do y to the 6th combined with y to the 2nd. 6 plus 2 is going to give me y to the 8th power. Remember, your final answer needs to stay in alphabetical order for you to have it 100% correct. Right, and coefficients always go in the front. All right, last problem, and then we'll be practicing several more of these in class. So if you aren't quite sold on it yet, you still have time. This one is not going to have any numbers attached to it other than exponents. All right, so if you look at the first parentheses, I need to pull this stuff apart because it's one big old product right now. It's negative 1 times x times y. The more you can separate things, the better you're going to be when you go to put them back together. Now this 2 has to go to everybody. We got to distribute that. So this becomes x to the 4th, because x squared squared is 4, and then y squared. So now looking at what you've got, you're ready to put things together. The coefficient, the only one you've got is this negative 1. So your final coefficient is going to be a negative 1. Now go back and put your x's together. I've got 1x right here and 4 x's right here. So now that means I have x to the 5th power. Then go back and get your y's. I've got 1y right here and 2 right here. So now that gives me y to the 3rd. So my final answer is negative x to the 5th, y to the 3rd. And it came from busting things apart and putting them back together, which is essentially what you're doing with these properties.